Let's talk about concepts and skills for a moment. As the Learning to Think Spatially report recommended, we must encourage an informed spatial thinking. In other words, rather than a vague notion that where things are is important, students must understand spatial concepts such as the interconnectedness of elevation with ecoregion zonation, relative and absolute distance, map projection, and Earth-Sun relationships. They must also understand spatial relationships or representations beyond maps to diagrams, globes, and satellite imagery. They must be able to use spatial skills in problem-solving contexts, looking at real-world issues, as I've outlined earlier. Geographer Reg Gollage, who I still greatly miss and one of my early career mentors, and still one of my heroes, identifies important spatial skills and understandings in many of his writings. First of all, one must be able to translate from one dimension to another, as in creating a two-dimensional map from a 3D Earth. One must understand the differences between distance properties such as adjacency, proximity, similarity, nearest neighbor, crow fly distance, and over-the-road distance. And finally, one must comprehend orientation and direction, including compass bearings, angular bearings, and clock face. The tower is at 2 o'clock from our trail's heading directions. A spatially skilled person, what is that? A spatially skilled person understands frames of reference, longitude, latitude, UTM, street numbering systems, and national grids. That person recognizes geographic associations such as the connection between downhill snow skiing and mountains and the relative lack of cities in desert areas versus a denser pattern in agricultural areas. The spatially skilled person must understand regions, everything from census tracts, police precincts, school districts, to ecoregions, production areas, countries, and biomes. Gollage points out that, quote, if you understand the spatial concepts that are part of nearly every facet of everyday life, from using spatial principles when packing the trunk of your car for a family vacation to walking safely out to the kitchen sink in the middle of the night without turning on the lights, you are thinking spatially. Indeed, you can help students transfer everyday spatial thinking into an informed spatial thinking so that they can grapple with the important issues of our time, from biodiversity to energy to epidemics. There are hundreds of excellent ways to teach spatial thinking, from gathering field data with your students to creating models of Earth-Sun relationships. One of the best ways to foster spatial thinking and analysis, in my view, is to use a tool that was created especially for spatial analysis: GIS, or Geographic Information Systems. GIS can be used to understand patterns, linkages, relationships, movement, regions, location, and place, from human systems to physical systems, to human-environment interaction. GIS can be used for studying issues at the local level to the regional, national, or global scale. It's multi-scale.